Hello, everyone. My name is Andrew Penland. I've been an assistant professor of mathematics at Western Carolina University since 2015. To start, I think some gratitude is in order. First, I want to profoundly thank the MAA Southeastern Section for this award. I know that there are many incredibly effective teachers, instructors, and professors of mathematics who work at colleges and universities all across the southeastern U.S. I am humbled and honored to think that I am one of them. Secondly, I want to thank my parents, the Reverend Terry and Amy Penland. From my early childhood to the time that they passed away in 2019, they taught me more than words can say. Even though I've learned a lot of valuable things about formal teaching methods and philosophies over the last 15 years, the work that I do as a mathematics teacher is still most influenced by them. Finally, I'd like to also thank my colleagues in the mathematics department at Western Carolina University. I was so fortunate to be a student here at WCU from 2006 to 2011, earning various degrees. I am so fortunate to work in a place that values teaching so highly. I've decided to call this talk Fun and Games. I hope that's okay with you. I know that many mathematicians are invested in the idea that what we do is very serious. And I don't disagree with that idea. However, I have a different perspective on mathematics than many mathematicians. I wasn't good at math in middle school, high school, or my first attempt at college, which happened somewhere besides WCU. For the first 24 years of my life, I felt the same way about mathematics as many people do. I hated it. It seemed like an arbitrary and pointless collection of rules, enforced only as a means of breaking the wills of children. In 2006, when I was a student at Haywood Community College, I was fortunate to have an instructor who helped change my view. His name was Mr. Paul Puckett. Now, this was my third try on Precalculus, and I was just hoping to pass so I could get my Associates of Arts degree. I didn't expect to like the class. But Mr. Puckett taught mathematics in a way different from what I previously knew. I distinctly remember him saying in class one day, "What people don't understand is that I get to play the most fun game anyone has ever played." And every day in class, Mr. Puckett would teach in a way that demonstrated this belief. Whether we were getting out string and tape to investigate the equation of an ellipse, or getting out our calculators just to, as he called it, clown around with the trigonometric functions, his enthusiasm was contagious. And one day, Mr. Puckett took me aside and told me that he had a problem that he wanted me to think about. And he made it seem like a super secret mission, which kind of intrigued me. And here's the problem that changed the direction of my life. We could call it the coin balancing problem or the counterfeit coin problem. There are 7 coins. We know that one coin is counterfeit and that the counterfeit coin is lighter than the others. We have a scale, a balance scale. So we can put coins on each side of the balance and see whether or not the scale balances. The question is, how many times do we need to weigh to find the fake coin? This is the setup. 7 coins, a balance scale. We can put coins on each side of the balance and weigh, and how many times do we need to use the scale to find the fake coin? My initial answer was 6, that you could do this in 6 ways. And I brought this answer to Mr. Puckett very excited, and he told me that I could improve it. So I went back and I thought about it some more, and then I brought the answer back to him again, and he told me I could improve it. I spent over an hour thinking about this problem, seriously, going through multiple sheets of paper. And if someone had just given me a formula for the answer, I would not have enjoyed that process at all. And I probably would be doing something very different right now. But the problem intrigued me and challenged me. It was something I could work on
but it wasn't easy.
But then once I had a solution of the problem, the real game began. So this was the first time I had ever seen the what if game, where you take a mathematical problem that you have solved and you ask what if? What if I changed this problem a little bit? How would the problem and its solution be different? So what if there are 8 coins instead of 7? What if there are 10 coins instead of 8? What if we don't know whether the fake coin is lighter or heavier? What if we don't know that there's only one fake coin? What if there might not be any fake coins? What if there might be 5 fake coins? The first mathematical game I learned was the what if game. And I love this game because you can apply it to any mathematical problem that you solve. What happens if I bump it to a different problem just a little bit? How do things change? I took Mr. Puckett's advice. I did take calculus at Western Carolina, and I did become a mathematics major. And I think that because I had the experience of problem solving before I had the experience of calculus, it really changed my experience throughout my time at Western. The faculty members at Western were absolutely wonderful, and I'm so thankful to have them as colleagues. But I went into calculus and the rest of my mathematical studies with an attitude of curiosity, because I had learned to see mathematics as a game. So I'd like to give 4 reasons that I think viewing mathematics as a game is valuable. And I'd also like to tell you some of my favorite mathematical games that I've played in calculus classes. 4 is an important number to me when it comes to teaching. I remember very clearly preparing to teach my first calculus class as a new PhD at Western Carolina, and I was so desperate for ideas that I opened the textbook. And when I opened the textbook, I saw something past the preview of calculus. 4 ways to represent a function was the first section in the book. The concept of the rule of 4 laid out in Stewart's calculus book that there are basically 4 ways of thinking about mathematics. You can use words, you can use a graph or visual representation, numerical or data-based representation, and symbolic or formula methods. And this can apply, I believe, to any idea in mathematics, not just the idea of a function. And I think it makes a fun game. So here's how I play the rule of 4 game. I look at my teaching materials and I ask, if I had to put them in each of these quadrants, what percentage of the material would go in each quadrant? And then for an extra fun bonus, I do the same thing with my exams. So play this game with me. Think about your most recent calculus exam that you either took or created. What percentage of the content fell into the verbal quadrant? What percentage fell into the visual quadrant? Playing this game has been very helpful for me, trying to say things like, if I had to explain the quadratic formula using only words, could I do it? If I had to explain the quadratic formula using only words with an odd number of letters, could I do it? Realizing that there are these different ways of thinking about math and pushing myself and my students to take their ideas and move them consciously around these different quadrants has been so much fun for me. So I share it with you and I encourage you to play it and see how it works. First reason I think it's helpful to think about math as a game or think about math through games is that games are fun. Many of our students are terrified of the subject, and being willing to take this alternative perspective gives them an entryway into it. Making memes is one of my favorite mathematical games. In calculus class, I always create some opportunities for students to create memes. And one of the really fun ways to do this is to have the students give you calculus memes during the first week of the class and during the last week of the class. So here are some of the memes that my students made. During week 1, most of the memes that they shared showed a distrust, an unease, and a distaste for the subject. But then and I allowed them to make mathematical memes throughout the year. And the memes that they made in the final week, I think, have a very different flavor. Yes, that is my face on Oprah's body. My apologies for that. And in fact, I think that some of these show quite a bit of mathematical insight. I know that mathematical memes might seem ridiculous. They are ridiculous. The point of them is to engage students' brains in a way that is non-judgmental and open and allows them to put their own stamp on mathematics from the beginning. A second valuable reason to think about math as a game is that games are fair, open, and accessible. When you think of any game that you enjoy, the rules don't prevent anyone from playing. I really enjoy a game that's called Give an Example of, because you can play this with any math thing. Give an example of a function. Then give an example of a polynomial function. Give an example of an even polynomial function. You can play this one for hours. I like playing this in my classes because it doesn't require calculation or what students typically think of as mathematical problems, but they are mathematical problems. And even playing this game going back and forth as the students think of things they could give examples of. It's a really fun game. Say, give an example of an even polynomial function that passes through 0, 0, and 1, 1. Or an example of an even polynomial function that passes through 0, 0, and 1, 1, and that has exactly 3 real roots. As you do this, you build confidence slowly. You remember different mathematical concepts and you see where trouble spots might be. Try asking one of your students, give an example of a differential equation. Or give an example of a vector space. And see what they say. Of course, assuming they've seen differential equations and vector spaces before. And then ask them to ask you for an example of something. Anyone can play this game, and it's really fun. On a related note, another valuable reason to think about math as a game is that games get people involved. We often say that math is not a spectator sport. Well, then let's not treat it like one in our classrooms. So here's an example of something I think is really cool. This was done by one of my Calculus 1 students named Tia Buznitz. At the beginning of the semester, Tia told me that algebra was a concern. But Tia was an outstanding visual thinker, an artist. And during the semester, Tia created this explanation of chain rule. Dating back to the ancient Romans, the turducken is a dish consisting of an entire chicken shoved inside of an entire duck, which are both then shoved into an entire turkey and slowly cooked to gluttonous perfection. Chain rule, a rule for differentiating composition of functions. The derivative of f of g of x is f prime of g of x times g prime of x, or dy dx is equal to dy du times du dx. The problem, find the derivative of f of x equals cosine of ln of 2x to the fourth, using turducken as an example. Step 1. Identify the parts of the function. F of x is equal to cosine of ln of 2x to the fourth. The cosine is the turkey, the ln is the duck, and the 2x to the fourth is the chicken. So we can view f of x as a chicken inside of a duck inside of a turkey, aka a turducken. Step 3. Put it all back together. Turkey prime times duck prime times chicken prime. Now step 2. Take the derivative of each part. First, we have turkey prime of duck times duck prime, or d turkey d duck equals negative sine of duck times duck prime. Then we need to calculate duck prime of chicken times chicken prime. D duck d chicken is equal to 1 over chicken times chicken prime. And finally, we need to calculate chicken prime. D chicken dx is 8x cubed. Turkey prime equals negative sine duck times duck prime. Duck prime is 1 over chicken times chicken prime. Chicken prime is 8x cubed. So f prime of x is negative sine of ln of 2x to the fourth times 1 over 2x to the fourth times 8x cubed, aka turducken prime. There you have it. The final important reason I think it's good to think about math as a game is that games are fun. Sometimes 4 really is 3 plus 1. I think that anyone who has ever written an exam question will agree with me that writing exam questions is a great mathematical game. You get to think about different levels of challenge, you get to think about different types of thinking about problems, You get to think about how long the questions will take and how many points they should be worth. It's a truly amazing game. In my 2019 Calculus 2 classes, I decided to share this game with my students. I let them write the exam questions. I made 40 to 60% of the exam based on their questions. This was a really interesting experience. A deep sea research team wanted to see what was at the bottom of the ocean. They dove in a submarine transmitting their velocity every hour, given by the equation f of x equals 0.01 x cubed, right parenthesis. Tragically, we lost contact after 10 hours, but there is still hope. You are tasked with finding them. Explain where you would look and why. You would probably recognize this more as a student question if I tell you that this original f of x was 0.000001 x cubed. For some reason, students think that putting longer numbers in the problems make them harder. But thank you to Gray Jenkins, one of my Calculus 2 students, who said I could use his question not only on the exam, but also in this talk. I realize that this isn't the talk some of you were expecting. There are lots and lots of great mathematical games, and I couldn't even list them all, of course. When people talk about mathematical games, they're often talking about things like Sudoku or Rubik's Cube. There are even more games like Set or NIM or two-player graph coloring that my students presented their research poster on. There are Toothpick Takeaway games. Other mathematical games have a different flavor. You can talk about things like Prisoner's Dilemma. And there are other great games that you can analyze using mathematics, like chess, basketball, 20 questions, rock, paper, scissors, and peekaboo. I chose not to focus on these games because A, there are other people who can provide more expertise than I can, and B, my time was limited. I wanted to focus on things that meant the most to me. So I have a challenge for students. Ask a faculty member their favorite mathematical game. And I have a challenge for faculty. Be ready for this question. One reason I've always been drawn to non-traditional teaching approaches besides lecture is, to be honest, I don't think I'm a very good lecturer. I'm very soft-spoken, and I tend to lose my train of thought. So getting students involved is the only hope I have of making the class be effective. When I teach, everything is about discussion, and I want this talk to be the same way. I really do enjoy talking about mathematics, but even more than that, I enjoy hearing other people's ideas. So if any aspect of this talk connected with you, if you have any questions, comments, or thoughts, I would sincerely invite you to email me at adpenland@email.wcu.edu and share your ideas. I want to thank you for coming to this talk, and I hope that you have enjoyed the conference, and I hope that I can see you all again in person before too long. Thank you, and take care.